So here we have delta equals to I plus E minus A. Okay, so this is the angle of deviation, a very important relationship between the angle of deviation and angle of prism. Okay, now come to our next topic, that is to find the refractive index of a prism. Here we have considered again the previous figure, okay, which I have drawn. Okay, what is the angle of minimum deviation? First we have to find the condition for minimum deviation. Okay, what is the minimum deviation? If the angle of incidence is increased gradually, okay, if the angle of incidence is increased gradually, then the angle of deviation first decreases, then attains a minimum value, and then again start increasing. Okay, as you can see in the figure, uh, in x-axis we have angle of incidence, and along y-axis we have angle of deviation, that is your delta. Okay, so if I increase the angle of incidence, first the uh, if the angle of incidence is increased gradually, then the angle of deviation, you can see angle of deviation in this particular axis, angle of deviation first decreases. Okay, first decreases and attains a minimum value. At this particular point attains a minimum value. Okay, so at this particular point the angle of incidence is equals to angle of deviation. Okay, sorry, angle of incidence equals to angle of deviation. Okay, so as you can see in the figure, if I increase this angle gradually, this refracted ray will be moving towards this direction. Okay, this is your angle of deviation. If I increase this particular angle, then first this angle will increase, and the point will reach where this emergent angle will be equal to the angle of this angle. Okay, this angle of emergent is equals to the angle of incidence. Okay, so at this particular point where the angle of incidence is equals to the angle of emergent is called the minimum deviation. Okay, is called the minimum deviation. When angle of deviation is minimum, the prism is said to be placed in the minimum deviation position. Okay, there is only one angle of incidence for which the angle of deviation is minimum. Okay, so at this particular point where I equals to E, delta equals to delta m, that is your minimum angle of deviation. So what we have concluded, for minimum deviation the angle of incidence should be equals to angle of emergent. Okay, so delta equals to I plus E minus A, we have the previous relation as you can see here. This delta becomes delta minimum at the minimum deviation condition. I equals to I, and angle of emergent becomes angle of is equals to angle of incidence. So I plus I minus A. So delta min equals to 2I minus A, or 2I equals to A plus delta min, or I equals to A plus delta minimum divided by 2. This is the value of angle of incidence. Okay, I hope you understand it very well. Okay, now we have the Snell's law. According to Snell's law, n1 sine theta 1 equals to n2 sine theta 2. So at point Q, as you can see, at point Q, apply the Snell's law at this particular point. So we get n1 sine I equals to n2 sine r1. What is n1 and n2? n1 is the refractive index of air, and n2 is the refractive index of this particular prism. Okay, and I is the angle of incidence and r1 is the angle of refraction. So at point Q, n1 sin I equals to n2 sin r1. This will be your equation number 1. Similarly at point R, this will be your angle of emergent, refractive index n1, again refracted angle r2, and refractive index will be n2. So n1 sine E equals to n2 sine R2. Okay, since as we have discussed at minimum for the minimum deviation I equals to E, so we can write here I equals to E. Then this equation becomes what? N1 sine I equals to n2 sine R2. So from equation 1 and equation 2, the left hand side of both the equations are same, then right hand side will also be same. So on comparing, we have n2 sine R1 equals to n2 sine R2. So this n2 and n2 will cancel out. So we have sine R1 equals to sine R2. If I take inverse of both sides, then we have R1 equals to R2. Okay. Now, as we have proved A equals to R1 plus R2 previously, okay, so A equals to, since R1 equals to R2, so A equals to R1 plus R2, or A equals to 2R1, or R1 equals to A upon 2. The refractive index is the refracted angle in terms of angle of prism. Okay, again at point Q, n1 sine I equals to n2 sine R1. So put the value of I. So what is the value of I? As we have discussed, I equals to A plus delta mean upon 2. Okay, and what is the, okay, and what is the value of R, or R1 equals to A by 2. Okay, so put in this particular equation, we have n1 sine A plus delta mean upon 2, or delta m upon 2 equals to n2 sine A by 2. Okay, so the final equation in terms of refractive index of our prism, that is n2 equals to n1 sine A plus delta m upon 2 divided by sine A by 2, where n2 is the refractive index of the prism. For a small angle, sine A plus delta m upon 2 equals to A plus delta m upon 2, and sine A by 2 equals to A by 2. Then this equation becomes what? N2 equals to n1 A plus delta m upon 2 divided by A by 2, where n1 is the refractive index of air, whose value is always 1, near about 1. Okay, so n2 equals to A plus delta m upon 2 divided by A by 2. Let us consider the refractive index n2 of prism is equals to n. So n, this cross multiplies this term with n2, so it becomes n into A by 2 equals to A plus delta m upon 2. So this 2 and 2 will cancel out, so we have n dot A equals to A plus delta m. Transfer this A towards left hand side, we have Na minus A equals to delta m, or delta m equals to A plus n minus 1. So delta m is called the minimum angle of deviation and is your refractive index of the prism. A is the angle of prism. Okay, so this is the very important relationship. Okay, so here we have the value of minimum angle of deviation. Okay, or this is your prism formula. This term is your prism formula. Okay, so two very important derivation and formula we have here. The question is always arise from these two particular formulas in your board exam, as well as NEET and JEE also. Okay, so this will be helpful for you. Okay, so this is the end of this lecture number 11. I hope you understand it very well, and for any queries you can write in comment box, or you can message me on your on my WhatsApp number personally. Please like and subscribe my videos. Okay, and if uh, is there any query, so you can ask me. Okay, thank you so much.